Hello everyone. In this video, we are going to look at exception and friend in C++. So the first part of the video, we're going to discuss exception. Exception refers to a problem that arises during the execution of a program. For example, while you are executing an arithmetic operation like n1 divided by n2, when n2 is 0, then there's a problem. So that's called the exception. C++ handles exception using 3 keywords. One is called a throw. You throw an exception. Another one is catch, like throw and catch. And another one is called a try. So let's take a look at how C++ uses these 3 keywords to build the exception handling mechanism. Now let's take a look at the division. I have a function here called the division. This division takes in 2 double and it does a checking. So if n2 is 0, then it's going to throw an error message. So this is a throw keyword. It's going to throw a constant char star, so it's a C string here, division by 0. If this isn't true, it just returns the result of n1 divided by n2. So that's division's logic. You throw an exception and you throw an error message when n2 is 0. Now let's take a look at the function. This is the main function, part of the main function that invoke division. So when you invoke division, since division, it's possible for division to throw an exception. So you put this code around a try-catch block. It's saying, I'm going to try to do this and catch an error message. It's constant char star. And the flow control, C++ use exception to transfer the flow control from one part of the program to another part of the program. For example, when this happens, when n2 is 0, this division by 0, it's going to throw an exception. When the exception is thrown, the flow control is transferred to the catch block right away, which means cout statement will not be executed if the exception was thrown. So the flow control will be transferred to the catch block right away. But if n2 is 5, not 0, or any other value other than 0, then the flow control, then the throw statement isn't executed, then your flow control just keep on going. So that's a normal execution. If this division function invocation throw an exception, the flow control is transferred to the catch block, then keep on going. So that's a basic about the C++ exception. Pretty much it's using throw, try, and the catch block. The try and the catch block, the try block, you put in the statement that's possible to throw exception, put those ones in the try block. And if one of the statement is in trouble, has a exception throw, then the flow control is going to be transferred to the catch block. Now let's take a look at another example here. So let's see this try block. Inside of this try block, we have a pointer to a car. It doesn't matter how the car class is defined because this pointer is a no pointer. So there's no car object at all. Then I'm trying to dereference a car, which what you're trying to do now, that's a problem. You're trying to dereference a no pointer. You cannot dereference a no pointer because when you dereference a car, it's not pointing to any car object. So what I'm trying to do is dereference this no pointer and ask for its type ID, runtime type ID, and ask for the class name. So this dereference operator is going to throw an exception here. And now we know this statement won't be executed because you're trying to dereference a no pointer. So at this line, the flow control is transferred to the catch block. And here we have two parallel catch block. One is saying I'm trying to catch out of range, and this exception isn't out of range, so it's going to skip this catch block and come down here. And it is an exception. Exception is a superclass of all exceptions. We're going to take a look at this one later. So any exception is an exception. So it match with this block. It's going to see out. This exception is an object. Inside this object knows how to do what. So what just usually just display the information about the exception. Alright, so you see the flow control here, we have two lines. Now let's take a look. So assuming if I create a new car object and this line doesn't fail, so the exception isn't thrown, the flow control will come down to this line. Now let's take a look at this line. Int list is a vector of integer, and it has 3 elements there. But I'm trying to access the 4th element because the index starts with 0. So this one will throw an out of range exception. If I comment out this line, the dereference no pointer line, this one will, this int list.add will throw an out of range exception, then you're going to catch this one and keep on going. So that's the flow control of try, catch, and throw. So we put the statement in the try block. Inside the try block, if one of the statement, the first one, if one of the statements throw an exception, the flow control is going to transfer to the matching catch block and execute the statement there. So usually in the catch block, this is very common what we do. We just display some information to tell what's going on. Alright? And you can also define your own exception. Let's take a look at this exception. You see I have a struct my exception extend public exception. This is a superclass of all the exception here. So we're trying to create my own exception and extend this one. So I'm a subclass of yours and override the what. The what just give you back a C string to tell what's going on there. Override that error message. Now let's take a look at how to use my own exception. So you see in the try block, I throw my own exception, and put in this statement just to test the flow control. So if this one gets thrown, then this one never gets executed because an exception happened. Then you have to go to the catch block. Then it catches this one and display the message there. Alright, so that's the basic of C++ exception. C++ exception, now let's take a look. C++ exception class is defined in the standard namespace. And here's a constructor and operator overloading and one major function here. You're supposed to override when you create your own exception. So the constant char star what. So this is a very useful function. Almost 90% of the time, you use the what function to display what's going on. And now let's take a look at the exception subclasses. You see derived types. You have this many of subclasses of exception and logic error. Logic error has its own subclasses. So those ones like out of range for the vector length error. You can take a detailed look at the logic error. And there's a runtime error. Runtime error has its own subclasses. So pretty much exception class is a superclass of all exception. Then two big subclass, logic error and the runtime error, they have their own subclasses. And here's some sample code about exception. So pretty much that's about exception. It's just the C++ way to transfer your program control from one part of the program, the part that might throw exception, to another part of the program, the part that handles exception. Alright, so the next topic we're going to have is called a friend. So friend is in pure object-oriented programming. we don't like to make friends. You will see why. So you have seen friend before when you overload the insertion operator from OStream class. Now let's take a look at this one. So we are familiar with linked list, and in our implementation, in my sample code before, I always make a node a private struct inside of linked list. The reason I make it a private struct is that struct is only accessible through linked list class, and I make it a struct because I want the linked list to have direct access to what's inside the node. Usually that's the data and the pointer to the next node. This is another, I want to show you another kind of implementation. You can make node itself a class. So when you make node a class, you see the private data, the private member will be the data member, the data it contains, and the pointer to the next node. And now for node class, if you don't provide if you provide access like set data, set next, for the client of node, it will be inefficient. For example, the only client for node here is linked list. You want linked list to have direct access to node's private data member because linked list uses it a lot. Linked list is the only client of node. So in that case, you can do it this way. You can say friend class linked list. So what you're saying, whenever you say a friend, that means, okay, whatever follows, it could be a friend class, it could be a friend function. So whatever followed, they're not part of this class, but they're friend of this class. So which means inside the linked list, that means all the member functions in linked list, they have direct access to the private data member of node. So that's a friend class. So that means the whole class is a friend of node class. Inside that class, any member function have direct access to the private data member of node. That's what a class means. You can also make a a function friend, not a class friend. A function friend, for example, here I have a function called a print node. This print node isn't a member function of a node. It's just another function. It's just another function, and judged from this declaration, it's just a global function called a print node. Print node says, give me a pointer to a node. I'm going to print the content of the node. And once you say print node is a friend of node class, then when you implement the print node, you have direct access to what's inside the node. So you can say a node big arrow data, a node big arrow next. You don't have to go through the public interface. You have direct access. So that's friend. So let's take a look. So you see class linked list. This linked list is a friend class of node. That means when you implement the constructor, the destructor, the public member function, you need to access the node. Then you have direct access to what's inside the node, which is the data and the next pointer. So that's what a class status means for this linked list class, because it's a friend class of node class. And now let's take a look at the print node. The print node is a standing alone function. It could be a global function. So here, it's a global function that print the content of the node. Since print node is a friend of node class, when you implement this print node, you have direct access to what's inside the node. So that's the idea of friend. Friend just means when you define a class, you can announce, I have a friend class, or I have more than one friend class, and I have a friend function. So this friend status just means those classes or those functions, they have direct access to the private data member of this node class. Whenever you say friend, that means those are not part of the node class, they're just a friend. The reason pure OOP doesn't like you to make friend is when you give this privilege to your friend, it's a good thing, they have direct access, they're happy. But what if later on you change the private data member? then they won't be happy anymore. Your friend will be really upset because their implementation directly depends on your private data member. If you modify them, their code need to be modified at all, so you offended your friend this way. So when you make friends, please be very careful. Think about, do you have to make this friend? Is this the only way to do it? So it's okay for linked list to be a friend class because that's the only client of Node. They're closely related. But in other scenario, you really need to think through, is this making friends deal is a good deal for you? Thank you.